Selective breeding. In this lesson, we'll look at the science and engineering practices of constructing explanations and designing solutions, as well as obtaining, evaluating, and communicating information. Our cross-cutting concepts consist of patterns, cause and effect, structure and function, and stability and change. Selective breeding. Over thousands of years, humans have altered the characteristics of some other organisms. Organisms such as crop plants and domesticated animals look and behave differently to the organisms they descended from thousands of years ago. The new characteristics of these organisms have been chosen by humans through selective breeding. So what is selective breeding? Selective breeding is the process by which humans breed animals or plants to develop useful characteristics. It is also known as artificial selection. Humans have carried out selective breeding for thousands of years. It has been used to breed food crops from wild plants and domesticated animals from their wild ancestors. The process of selective breeding. In selective breeding, animals, plants, or anything else with desired characteristics are bred together. Some of the offspring will show the same desirable characteristics. These offspring are often bred together. Over many generations, the characteristics of the population change. The desirable characteristics become a normal characteristic for every organism within the population. So let's look at an example. Selective breeding of cows. Choose the most suitable cow. Farmer Jones wants to produce a herd of cows that have a good milk yield, high fertility, and are his favorite color, which is brown. Which cow should he breed with his bull? This cow has high fertility, a large milk yield, and it's his favorite color. Breeding the bull with this cow would create an offspring that also has high fertility and have a substantial milk yield. Now, which of the offspring should Farmer Jones use in the next generation of selective breeding? Most likely he would choose this organism. Inheritance of genes. Selective breeding works because desirable characteristics are controlled by genes. Genes are genetic information which is stored inside the nucleus of our cells. Genetic information is passed from parents to other offspring. This causes offspring to share some of each parent's characteristics. Explaining differences. Offspring from the same parents have different characteristics to each other. This is because the genes that end up in each new organism are chosen at random from the parent's genes. This means that each new organism is very unlikely to receive the same set of genes to other offspring from the same parent. Selective breeding in genes. When two organisms with desirable characteristics are bred together, only some of their offspring will inherit the genes for the desirable characteristic. Offspring that show the characteristic are bred together, passing on their genes to the next generation. Over many generations, most of the offspring will have genes for the characteristic that is desired. Domestic animals. Domestic animals have been selectively bred from wild animals to be tame enough for animals to use for work, food, or to keep as pets. Beef cattle have been bred to produce high quantities of meat. Dairy cattle have been bred to produce high quantities of milk. Sheep have been bred to produce high quantities of meat and to grow large amounts of wool, which humans can use to make fabrics and cloth. Dogs. Dogs have been bred as pets. There are hundreds of breeds, all originating from wild wolves. Most dogs have been bred to be gentle in nature. They have also been bred for the appearance, fur color, body size, and ear shape have been used for selective breeding. Some dogs have been bred with a focus on behavior. For example, farm dogs are used for herding sheep. Selective breeding in plants. Selective breeding has been used to produce crop plants that give high yields. The yield is the amount of food produced by a crop. Crop plants have also been bred to be disease resistant. This reduces crop losses and the amount of chemicals that need to be added to fields to protect them from disease. Crops have also been bred to have larger seed heads so that they produce a higher quantity of food. Stem height has been used for selective breeding to make crops easier to harvest, using the machinery that we have for that harvesting process. Selective breeding has also been used to create plants that have characteristics that are desirable to gardeners. So what characteristics might be desirable to a gardener? Oftentimes, large-headed flowers or color variations are something that gardeners desire. There are hundreds of varieties of roses. Each variety has a unique appearance depending on the characteristics selected by the grower. Selective breeding and natural selection. Natural selection is another process that causes the characteristics of organisms in a population to change over time. So how is natural selection similar to selective breeding? How is natural selection different to selective breeding? This image shows black and white peppered moths. During the Industrial Revolution, tree trunks near cities were turned black by pollution. The black wing mutants were better camouflaged against these tree trunks than the original white peppered moths. This meant that there was a decrease in the number of white peppered moths in the population. Over time, as pollution decreased, the tree bark returned to their normal color. This resulted in a decrease in the black peppered moths and an increase in the white peppered moths in the population. Both selective breeding and natural selection involve characteristics that are inherited by offspring through genes. In selective breeding, a person decides which characteristics are desirable. In natural selection, the environment determines whether a characteristic is desirable. Natural selection leads to organisms with characteristics that are adapted to their environment. Selective breeding leads to organisms with characteristics that are useful to humans. So let's look deeper at the differences or similarities between selective breeding and natural selection. Selective breeding produces animals and plants that have characteristics which are useful to humans. Natural selection produces animals that are well adapted to their environment. Can you tell which animals and plants are produced by selective breeding? Are these statements about selective breeding true or false? The taste and color of an apple can be decided by selective breeding. This is true. Both taste and color can be determined by selective breeding. Number 2, the speed that a rabbit can run is a result of selective breeding. I suppose we probably could choose for selective breeding. My guess is that having a predator in the environment might be a more appropriate method of choosing for a rabbit that has high speeds. So in this case, the speed at which a rabbit can run is more due to natural selection, not selective breeding. Wheat is selectively bred to produce more grain per plant. This seems to be a benefit to humans. Modern wheat crops yield more grain per plant than older varieties. Cows are selectively bred so that they yield more milk. This is definitely something that we do on a regular basis. Farmers can choose to breed cows that produce a lot of milk. A tiger's strength and speed are due to selective breeding. This is definitely false. A tiger's speed and strength are the result of natural selection, nature choosing for those traits that allowed for them to better survive in their environment. The patterns and markings on a goldfish are a result of selective breeding. This one might be kind of tricky. The correct answer is true. Goldfish and other fish, such as koi, are bred for color and markings. Lemons are selectively bred for size and taste. There are a number of different varieties of lemons, just like apples, and we selectively breed for size and taste in them. Butterflies are bred for their speed. Surprisingly, butterfly farms do exist, but they don't breed butterflies for their speed. Rather, maybe for coloration. Cats can be selectively bred to produce varieties with long hair. This is true. Some long-haired cats develop naturally, while others, like the ragdoll, are specifically bred for that trait. So thinking about selective breeding, here's an activity to consider. Can you think of any characteristics in crop plants or domesticated animals that are useful to humans, but not to the organism if it were to live in the wild? Explain why the characteristics are useful to humans, and then explain why the characteristics would not be useful for the wild organism. Some examples that I've come up with are thick woolen sheep. This might be too heavy in the wild, but useful for the production of wool for humans. Short legs in dogs, like this wiener dog. It would make it difficult for that dog to run quickly, meaning that it would probably have a harder time finding food or escaping from predators. But in humans, see this as a desirable trait. High mass in cattle or pigs. It makes it difficult for these animals to move, but it might increase the yield for meat with humans. Issues surrounding selective breeding. Selective breeding can involve repeatedly breeding related organisms together over several generations. This may lead to inbreeding. Inbreeding can result in organisms being more susceptible to disease, having a shortened lifespan, and an increased likelihood of inherited defects. For example, some dog breeds suffer from high rates of disease and have difficulty in walking due to extreme body shapes. There are a number of other examples where selective breeding, which may have led to interbreeding, causes organisms' gene pools to shrink and higher rates of disease are exhibited.